Electrolytes are compounds that split up into ions when they're dissolved in water. Non-electrolytes are compounds that do not split into the ions when they're dissolved in water. Electrolytes are important because they provide access to ions. And that can be useful in synthetic processes where you need access to a certain ion for the reaction to occur, or it can be useful in the sense of making water more conductive. Electrolytes produce ions, and ions help conduct electricity within the solution. And there are different categories of electrolytes. We've already mentioned electrolytes versus non-electrolytes, but within the category of electrolytes, we have two subcategories, strong and weak. Strong electrolytes are compounds where, when they dissolve, nearly every compound that gets dissolved splits up into its ions. Very few of the compounds that dissolve remain associated, with the ions still stuck together. Another way of saying this is that when the compounds dissolve, there is almost 100% dissociation. The ions dissociate from one another. And a couple of examples for strong electrolytes would be any of the water-soluble ionic compounds and the strong acids. So an example of a water-soluble ionic compound would be something like NaCl, sodium chloride. If you take solid sodium chloride and you dissolve it in liquid water, the sodium chloride will split up into its component ions, sodium plus and chlorine minus, the chloride ion. And if you look at the states of matter in the equation that I've shown, you'll see that the solid and the liquid, when they mix, produce ions that are aqueous. The ions are solvated by the water. And in the second example, HCl splitting up into H plus and Cl minus, again, you'll notice that we have the state of matter aqueous, implying that all of these things are happening in solution. The other type of electrolyte is a weak electrolyte. And weak electrolytes are compounds that, when they dissolve, only some fraction of the compounds will split into ions at any given time. So weak electrolytes, because only some of the compounds dissociate and some do not, these represent an example of equilibria. So this is one of the times where we use the equilibrium arrows. So the most common weak electrolytes that you'll encounter are the weak acids. For example, something like acetic acid, which is the main component of vinegar. In any given sample of dissolved acetic acid, only about 1% of the acetic acid molecules are going to split up into their ions. At any given time, 99% of those acetic acid molecules are going to be present as the molecular acetic acid. And the extent to which these molecules dissociate varies by compound. So some things like acetic acid dissociate about 1%, other things dissociate more, other things dissociate less. It really depends on the molecule in question.